Welcome to aminacademy.com. In physics, regarding mechanical properties of solids, let us continue. Now, let us discuss first volume stress or hydraulic stress. When the deforming force or applied force acts from all dimensions, resulting in the change of volume of the object, then such stress is called volumetric stress or bulk stress. In short, when the volume of body changes due to the deforming force, it is termed as volume stress. Look at this figure here. The force is applied in every phases. Due to that, its volume is reduced. So the opposing force given by this material object is called volume stress. Here, let vector F be a force acting perpendicular to the entire surface of the body. It acts normally and uniformly all over the surface area A of the body. Here the surface area of each face is surface area A. Such a stress which produces change in size but no change in shape is called the volume stress. While applying the forces equally all phases, the size is changed but shape is not changed. Here the volume stress is the formula equal F by A. Volume stress equal force by unit area. Volume stress produces change in size without change in shape of body. It's called hydraulic or hydrostatic volume stress as shown in figure here. Now, next volumetric strain. It is the ratio of the change in volume of your body to its original volume. If V is the original volume of the body and V plus dV is the volume of the body under the action of normal stress, the change in volume is dV. Therefore, volume strain is delta V, change in volume by original volume. Here, no unit because same units ratio, there is no unit for this. Here, when a deforming force acting on a body produces change in its shape of the body, that is called a shearing stress. Now, this is volume strain. Next is shearing stress. Shearing stress defined as a type of stress that acts coplanar with cross section of material. Shear stress arises due to shear forces. They are the pair of forces acting on opposite sides of the body with the same magnitude and opposite direction. Shear stress is a vector quantity. Look at here, a body is fixed here. Suppose the face is fixed here. A force, tangential force is applied like this. Due to that, it is sheared. Now, shear stress is the formula equal tangential force by area, cross area. This is a shear stress. That means this force divided by the base area, the cross-sectional area of the object. Next, shear strain. Shear strain occurs when a sideways force is exerted on a medium. A shear force wave may be generated that travels perpendicular to the direction of the applied force. Particle motion of a shear wave is perpendicular to the direction of the propagation. Now this force, shear force is this side, also in opposite direction also it acts. Now shear strain we will discuss further about. Therefore, shear strain is, we can write as delta L by change in length by original length is equal tan theta. Here, this is a shear strain. Change in length by original length is called shear strain. Next, Hooke's law. Hooke's law is an empirical law which states that the force F needed to extend or compress a spring by some distance x scale linearly with respect to the distance, that is Fs equal to Kx, where K is a constant factor characteristics of the spring, that's a spring constant or its stiffness, and X is small compared to the total possible deformation of the spring. Look at here. Here, this is an ideal spring. There is no load. Here, if you apply some load, it extends some distance x. Suppose if you apply more load, its extension is also more. Therefore, the force on the friction is directly proportional to the extension of the spring. Therefore, F is equal to minus Kx, where K is a spring constant and X is a deformation, that is varying length. Within the elastic limits, stress is directly proportional to the strain. Mathematically, Hooke's law states that the applied force F equals to the constant xk times the displacement or change in length x, that is F equal to Kx, is a Hooke's law. Hooke's law is a state within the elastic limit, stress is directly proportional to the strain. Therefore, we can write stress by strain stress by strain equal constant. The constant is called the modulus of elasticity. The modulus of elasticity of a material is the ratio of the stress to the corresponding strain. It is defined as the slope of the stress strain curve in the elastic deformation region, and depending on the nature of the material, the maximum value of the stress up to which the stress is directly proportional to the strain is called elastic limit. The stress strain curve we will discuss in detail now in future we will do. Here this relation can be expressed, we can show in a stress strain diagram in next video. Now so far you understand about Hooke's law, shearing strain, shearing stress, and volume strain and volume stress like this. These are mechanical properties of solids we explain. We have done. Please subscribe our YouTube channel.